Hello friends, you are welcome to another interesting video on this channel. In today's video, we are going to discuss the concept of isotopy. But recall that in our previous video, we talked about the concept of atomic number and mass number. And we defined atomic number as the total number of protons present in the nucleus of the atom. And we defined mass number as the total number of proton plus neutron present in the nucleus of the atom. So in essence, the proton number tells us the atomic number, and the sum of the proton number and neutron number tells us the mass number for that particular element. So that will form the basis for today's class. In today's video, we are going to look at the core concept of isotopy. And what is isotopy in chemistry? Isotopy is simply a phenomenon whereby atoms of the same element, so the first keyword we have here is that we have atoms of the same element, and since they are atoms of the same element, we expect that they should have the same atomic number, because we said that every element has a specific atomic number. So isotopy is simply a phenomenon whereby atoms of the same element have the same atomic number, so they have the same atomic number, but they have different mass number. So in essence, we have elements that have various atoms such that these atoms have the same atomic number because they are from the same element, but they have different mass number. So we can see in this case, this is carbon 12 and carbon 14, same element, which is carbon, and we expect that they should have the same atomic number of 6, but in this case they have different mass number. In oxygen 16 and oxygen 18, they are from the same element, so they should have the same atomic number, which is atomic number 8, but they have different mass number. And still on chlorine 25 and chlorine 27, they have the same atomic number, which is 17, but different mass number of 35 and 37 respectively. So in chemistry, when atoms of the same element have the same atomic number but different mass number, we call those atoms isotopes. So this is an isotope of carbon and this is an isotope of carbon. So basically, isotopy is simply a phenomenon whereby atoms of the same element have the same atomic number but different mass number. And why do they have different mass number? The singular reason is due to the difference in the number of neutrons that this atom possesses. So in essence, isotopy is due to the difference in the number of neutrons or the neutron number that the various atoms possess. Neutron number. So we can go further and say that isotopy is simply a phenomenon where the atoms of the same element have the same atomic number, different mass number, and also different neutron number. If we look at carbon 12, we find out that the number of neutrons present becomes 12 minus 16, which will give us 6 neutrons, and in this case 14 minus 6 will give us 8 neutrons. So we can clearly see that they have the same atomic number, different mass number, and different neutron number. So atoms that exhibit this phenomenon of isotopy, they are referred to as isotope. So we can call carbon 12 as an isotope of carbon, and also carbon 14 as an isotope of carbon. So also oxygen 16 and oxygen 18 are both isotopes of oxygen. Chlorine 35 and chlorine 37 are both isotopes of chlorine. So also hydrogen, we have hydrogen 1, which is known as protium. We have hydrogen 2, which is known as deuterium, and hydrogen 2, which is known as tritium. These various atoms are called isotopes of hydrogen. Another relevance or another application of isotopy in chemistry is that due to the concept of isotopy, the relative atomic mass, which we sometimes call RAM, of elements are never whole number. This is the reason why we find out that the relative atomic mass of the elements we have in chemistry are always in decimal. For example, the relative atomic mass of chlorine is about 35.5. And now move on to look at the calculations under isotopy. on the board we have a question which says, given that the percentage abundance of chlorine 35 and chlorine 37 are 75% and 25% respectively, calculate the relative atomic mass of chlorine. Now we can simply link the concept of relative atomic mass and isotopy using this formula. The formula says that the relative atomic mass is equal to the percentage abundance of the first isotope, times the mass number A of the first isotope plus the percentage abundance of the second isotope times the mass number A of the second isotope. So we have the percentage abundance of the first isotope times the mass number of the first isotope. Here we have percentage abundance of the second isotope times the mass number of the second isotope. So there are cases where we could have even up to 3 isotopes. So it will become plus the percentage abundance of the third isotope times the mass number of the third isotope. So if you have 4, you keep adding the percentage abundance and the mass number. So in this question we have just 2 isotopes, which are chlorine 37, chlorine 35 rather, and chlorine 37. So in this case, the relative atomic mass is equal to the percentage abundance of the first isotope. So let's take this as our first isotope and this as the second isotope. So in this case, the percentage abundance for the first isotope is what? 75%. So the percentage abundance is 75%, that's 75 over 100, times the mass number. Recall that A stands for the mass number of atoms. So the mass number of the first isotope is 35. This gives us times 35 plus percentage abundance of the second isotope is 25%. That's 25 over 100 times the mass number of the second isotope, which is 37. So that's times 37. So we have the relative atomic mass of this to be, when we simplify this, we end up getting 26.25 plus, when we simplify this, we end up having 9.25. So when we add up these values, we have the relative atomic mass of chlorine to be 35.5. So remember that we said that the relative atomic mass of elements are never whole number due to the concept of isotopy. So our second question says that we have 2 isotopes, X12 and X14 of a particular element, and they exist in the ratio 2:1. The question says that we should calculate the relative atomic mass of X. Now it simply means that X12 exists in ratio 3 and X14 exists in the ratio of 1. So in this particular question, we don't have the percentage abundance. So how do we calculate this question? So we simply calculate the relative atomic mass by using this formula. The relative atomic mass is equal to the fraction of the first isotope. So let's say the fraction of the first isotope times the mass number A plus the fraction of the second isotope times the mass number of the second isotope A. So if you have the third isotope, it will simply be the fraction of the third isotope times the mass number. So what's the fraction about here? So the relative atomic mass is equal to the fraction. So let's take this as our first isotope and this as the second isotope. So the fraction of this first isotope becomes, the ratio of X here is 3 over the total ratio, which is 3 plus 1, that is what? 4, times the mass number, which is 12, plus, for the second isotope, which is X14, each fraction is 1 over the total ratio, which is 4. It should simply be the total ratio, 4 times the mass number is what? 14. So can I go ahead to simplify these values? So the relative atomic mass, when we simplify this should give us 9, and this should give us 3.5. So when we add up this, the relative atomic mass is equal to 12.5. So in this case, this is different from the previous question we took, because in this case we don't have the percentage abundance, but we have the ratio in which this isotope exists. So to get that, we are simply going to use the fraction, not percentage abundance, times their mass number for the first isotope plus the fraction of the second isotope times the mass number of the second isotope. So in essence, the fraction for the first isotope, which is this, is 3 over the total, which is 4. If they exist in 3 ratio 2, it will be 3 over 5. But in this case, it is 3 plus 1, which is 4. So plus the fraction of the second one, which is 1 over a total of 4, times the mass number, which is 14. So when we simplify this, we get 12.5. Recall that the relative atomic mass of elements are not whole number due to the concept of isotopy. Before we end this video, there are other important concepts we must look at in addition to the concept of isotopy, which are isobars and isotones. We want to talk about isobars. Isobar is just a phenomenon whereby atoms of different elements, take note of that keyword, we have different elements. Since they are different elements, they should have different atomic number. So hence they have different atomic number, but they have the same mass number. If you look at carbon 14 and nitrogen 14, you'll find out that they are different elements, carbon and nitrogen. Hence they will have different atomic number, but in this case they have the same mass number, making them to exhibit the phenomenon of isobars. So in exam, you can simply remember that bars are things above. So it means iso means equal or same, meaning they have the same mass number but different atomic number, and they are of different elements. So the next concept we look at is isotones. In isotones, it's a phenomenon whereby atoms of different elements, recall the word different elements, because they are from different elements, they will have different atomic number. In this case, they have different mass number. They have different mass number, but in this case, they have the same neutron number. So in this case, very clear, they are different elements, they have different atomic number, different mass number, but the same neutron number. So if we look at these two examples, we have nitrogen 14 and oxygen 15. Different elements, different atomic number, different mass number, but we find out that the neutron number in these two atoms are the same. So let's solve for that. So in this case, we have for nitrogen, the neutron number N will be 14 minus 7, and that will give us 7. In this case, the neutron number will become 15 minus 8. So the neutron number will give us 7. So we find out that in these two atoms, they have the same number of neutrons, different elements, different atomic number, and different mass number. So in this case, we can simply say that they exhibit the phenomenon of isotones. So in an exam, you can still remember that iso means same or equal, and you can see this word N. So remember they have equal or the same neutron number. So friends, I hope you enjoyed this video and you actually learned something from this video. Don't forget to like this video. Also, do well to drop your questions and suggestions in the comment section of this video. And if you are new to this channel, don't forget to subscribe to this channel and also click on the notification icon so that whenever we release any new video, you always get informed. Till I see you in my next video, do have a wonderful time.